Software backups ensure the availability and integrity of an organization's critical data and systems. They're a vital safety net in case of hardware failure, data corruption, or cyber attacks, such as ransomware. Regular testing and verification that backups will work when needed is crucial to ensuring the reliability of the recovery process. Simple backups may be easy to put into place, but ultimately they fail for a number of reasons. When vast amounts of data are needed to be backed up, scalability becomes a concern due to the data's size and complexity. Simple backups may take business-critical systems offline or cause performance issues while the data is being copied. Greater granularity and customization to target specific applications and data sets are beyond the scope of simple backups. More advanced backup techniques may be required, such as data encryption, access control, and audit trails. Disaster recovery plans and centralized management are part of an enterprise backup strategy, while simple backup techniques may not support advanced features like off-site replication and automated failover. Advanced backup techniques typically include the following features: support for virtual, physical, and cloud environments, data deduplication and compression so that storage space is optimized, instant recovery and replication for quick failover, ransomware protection and encryption, granular restore options at the file, folder, and application level, reporting, monitoring, and alerting tools for effective management, and integration with popular virtualization platforms, cloud providers, and storage systems. Data deduplication is a data compression technique that optimizes storage space by identifying and eliminating redundant data. Instead of storing multiple copies of the same data, deduplication stores a single copy and creates references or pointers to that copy for all other instances. Deduplication can be performed at different levels, such as file level, block level, or byte level. This significantly reduces storage requirements and speeds up data transfers. Backup frequency is an issue that needs serious consideration before a backup plan is implemented. Organizations with highly dynamic data or that must comply with regulatory mandates may choose to back up more frequently to minimize the risk of data loss. On the other hand, businesses with data that does not change often or is not subject to regulatory oversight may choose less frequent backups. Depending on the frequency of data changes, the backup cadence may differ drastically between two organizations, yet result in the exact same risk of data loss. A business can choose from on-site or off-site backups. An on-site backup stores data locally, usually in the same location as a protected system, and uses devices such as hard drives or tapes to provide rapid access and recovery. An off-site backup involves transferring data to a remote location to ensure protection against natural disasters, theft, and other physical threats. Ransomware is a cyber attack in which critical data is encrypted and all unencrypted copies are permanently deleted. The attackers then demand to be paid in exchange for the password that will decrypt the files. Ransomware may also attack backup infrastructure, therefore hindering recovery efforts and further exacerbating the attack's impact. Recovery from backups must be properly tested periodically. A full recovery test involves restoring an entire system from a backup to a separate environment to verify the fully functioning and recovery system. A partial recovery test only restores selected files, folders, or databases to validate the integrity and consistency of the data subsets. Simulating a disaster recovery scenario, such as hardware failures or ransomware attacks, can provide valuable insights into a company's preparedness and resilience. Recovery validation strategies must be carried out as backups can complete with 100% success, but mask issues until the backup set is used for a recovery. Additionally, many organizations are unaware of how long it takes to perform a recovery and how this extended length of time can impact operations. A snapshot captures the state of a system at a specific point in time. There are 3 different types of snapshots: virtual machine or VM, file system, and storage area network or SAN. A VM snapshot captures the state of a virtual machine, including its memory, storage, and configuration settings. This allows administrators to roll back the VM to a previous state. Examples include VMware vSphere and Microsoft Hyper-V. A file system snapshot captures the state of a file system at a given moment, enabling users to recover accidentally deleted files or to restore previous versions of files in the case of data corruption. Examples include ZFS and BTRFS. A SAN snapshot is taken at the block-level storage layer within a storage area network. It captures a state of the entire storage volume, allowing for rapid recovery of large data sets and applications. Examples include NetApp and Dell EMC storage systems. Replication and journaling are 2 data protection methods that ensure data availability and integrity by maintaining multiple copies and tracking changes to data. Replication creates and maintains exact copies of data on different storage systems or locations. A practical example of replication is database mirroring, where primary and secondary mirrored databases are maintained simultaneously. Any changes made to the primary database is automatically replicated to the second database, ensuring data consistency and availability if the primary database encounters issues. Journaling records changes to data in a separate, dedicated log known as a journal. Journaling enables a system to identify and undo any incomplete transactions that might have caused inconsistencies, or to replay transactions that occurred after the full system backup was completed. This provides a greater level of granularity for restoration and greatly minimizes data loss. A practical example of journaling is the use of file system journaling, such as the Journaled File System or JFS, or the New Technology File System or NTFS with journaling enabled. Remote journaling, SAN replication, and VM replication are advanced data protection methods that implement availability and integrity. Remote journaling creates and maintains a journal of data changes at a separate remote location so that data recovery and business continuity are covered in case of local failures. SAN replication duplicates data from one SAN to another in real time or near real time. This technique involves synchronous replication, which guarantees data consistency, and asynchronous replication, which is more cost-effective but may introduce a lag before data is an exact duplicate. VM replication creates and maintains an up-to-date copy of a virtual machine on a separate host or location, ensuring that a secondary VM can quickly take over the workload if the primary VM fails. Encryption of backups is essential for multiple reasons, primarily data security, privacy, and compliance. By encrypting backups, we add an extra layer of protection against theft or unauthorized access. Copies of sensitive data stored in backup sets are often overlooked, so encryption there is key.